What is up, guys? Welcome back to another simplified astrophysics video. This video is going to be another video on stars and astrophysics history. I'm going to talk about how we classify stars based on their light-emitted spectrums and the history of the astronomers who discovered this, many of whom were female computers hired by Harvard Observatory in the late 1890s. Before we get started, I do recommend you check out my video on stars and stellar evolution for some basic background, especially if this is a new topic for you. Alright, so by the late 1800s we had seen plenty of stars. We knew they were all around us and we even had names for them. But we didn't really know much about these stars. We didn't know what they were made of. We didn't understand their chemical composition. And we didn't know just how enormously large, bright, and hot they were. So in the late 1800s, we only understood the astronomy of where these stars were located and how to find them. But we didn't exactly understand the physics and the chemistry that took place in these stars. That's where spectroscopy comes in. In astronomy, spectroscopy is simply the analysis of the light and all the electromagnetic radiation that comes from the stars. In the late 1890s, Harvard Observatory received a quite generous amount of funding from the estate of Henry Draper to use spectroscopy to study stars. Harvard Observatory Director Edward Pickering established a massive project called the Henry Draper Memorial to do this. The Henry Draper Memorial would have Harvard Observatory use telescopes to take pictures of as many stars and their light spectrums as possible. They would then amass a massive collection, almost like a library, of pictures of these stars' spectrums. Then they would study these spectrums to make conclusions about stars in general. And here comes the historically significant part. Director Pickering hired computer analysts, which are just basically some analysts, to do the spectroscopy analysis at Harvard Observatory. And most of these computers were women, which was a big move considering it was only the 1890s. Many of these women were graduates in astronomy, physics, and chemistry from some of the new women's colleges that had recently been established in the mid to late 1800s, such as Wellesley, Radcliffe, Vassar, and more. Employment was no easy feat for these women, and Pickering generally paid them a fraction of the wage that would be paid to men. The stories in which these female computers were hired are pretty interesting. One of the first female computers that Director Pickering hired was Williamina Fleming, who was his Scottish maid. Director Pickering quickly recognized her abilities in math and physics and hired her, and she soon took up a directing role in the Henry Draper Stellar Classification Project. Let's turn our attention to the discoveries that these astronomers made. The astronomers of Harvard Observatory began taking as many pictures of the stars that they could. They then photographed the light spectrums of those stars onto glass plates. The computers that Pickering hired began examining and analyzing those light spectrums as part of their research. When analyzing the light spectrum of a star, one can determine its chemical composition. This was a discovery made in the early 1800s by Bavarian astronomer Joseph von Fraunhofer. Fraunhofer found light spectrums to contain lines, either colored or black. The positioning of those lines differed depending on whether different chemical elements were in the light. If the light was coming from an object made of sodium, it would have Fraunhofer lines that correspond to those of sodium on its spectrum. If the light was coming from an object made of helium, it would have Fraunhofer lines that correspond to those of helium on its spectrum. And if the light was coming from an object with both sodium and helium, it would have Fraunhofer lines that corresponded to both elements on its spectrum. Take a look at this diagram of Fraunhofer lines. As you can see, different elements have lines at different positions, allowing scientists to identify chemicals in the light. From the enormous amounts of pictures of stars they took, the computer analysts at Harvard had access to a literal library of stellar spectrums. They analyzed the Fraunhofer lines on those spectrums. From such analysis, they made amazing discoveries in astronomy. Annie Jump Cannon devised the modern stellar classification system in astrophysics. By studying thousands of stellar spectrums, she devised a way to group and classify them. Stellar spectrums, based on their similarities, have been grouped into 7 classes named after letters. Cannon's analysis ordered these letters based on decreasing temperature into the following order: OBAFGKM. Henrietta Swan Leavitt unearthed a relationship between a star's brightness and its luminosity. Her research found that brighter stars have a longer period, or the time it takes to complete a full orbit. The law that she discovered between period and luminosity was used in the Hertzsprung-Russell diagram to organize stars, and it was also used by Edwin Hubble to prove the expansion of the universe. And Cecilia Payne tied astronomy to quantum mechanics and discovered the reason for the Fraunhofer lines in light spectrums. She also found that the main two elements of every star are hydrogen and helium. Her work confirmed that Fraunhofer lines are the result of ionizations of electrons in the star's chemical elements. She also shed light that hydrogen and helium are the only two significant constituents of a star. These are just a few of the many discoveries by the computers of Harvard Observatory and several different other observatories. After all, amazing things begin to happen when you let half of the population into science. Those three discoveries by Cannon, Leavitt, and Payne are probably the three most well known. Recapping, Annie Cannon created a classification system for stars based on their temperature, OBAFGKM. Henrietta Leavitt determined a law between the period and luminosity of stars, a direct correlation between the two, and that law was used to determine the expansion of the universe. And Cecilia Payne applied quantum mechanics to astronomy and found that the main two chemical constituents of a star are hydrogen and helium. From these discoveries and many more, we've come to learn so much about stars through the lenses of physics and chemistry, which has enabled a massive amount of knowledge and research. Well, that is all I've got in this video today. I really do hope you enjoyed it, and I really do hope you learned something new. If you did enjoy that video, please leave a thumbs up to show your support, because that really helps out a lot. And also, don't forget to press that subscribe button. That is also very useful. And don't be afraid to leave any questions, comments, or concerns down in the comment section below. I'll do my best to get back to you. And I will see you later.